Hello. Hi, guys. Welcome to presentation titled Actor-Based Approach in Practice for Swift Developers. I'm Bartosz Polaczyk and work at Grand Parade, part of Wheeler Hill. It's a British bookmaker. Today we'll talk about actors, so I'll introduce into a problem, some historical background. Then we will talk how can it be useful in mobile world, iOS, maybe also in Android. Then we come into core part, implementation. And we'll finish with some feature that maybe will be used by Swift language, Swift compiler. So we got a lot of topics to cover, so let's get started. Actors. Actors are actually not a new idea. It was introduced in 1973 by Carl Hewitt, and as he said, he was inspired by physical models, general relativity and quantum mechanics. And at the beginning, it was just a theoretical approach to how to program, but very quickly became a foundation for existing real distributed language, Erlang. It's used in telecommunication industry that requires high reliability. A couple years ago, developers revisited actors and released successful library in Scala and also C#, F#, akka.net. So first, let's think about what actor is. Actor, it's a main building block of your application. At least in theory, in the pure actor world, we will have only actors for our application. So it's a building block that builds up your entire application and has several properties. Property number one is that every single actor has a unique address, and that address identifies given module, given actor. Second property is that actor receives messages from different parts of the system, and messages are the only way of communication between elements in actor world. Third one, that is very important for us, that actor can process, one single instance of an actor can process only one message at a time. Next one, how actor can react on received message. Only 3 possible ways to do that are allowed. First one, by creating new actor. First one is reading or writing into its local state. Second one is creating new actor. And third one, sending message to other actor. Now let's think what are limitations, what is prohibited. Because we've got full fire and forget mechanism, none of actors can actually wait for response from different part of a system. So there's fully fire and forget, we are sending message and forgetting about that. Second problem is that from within an actor, we cannot mutate any global state, only our local state, challenging. Within an actor, we don't have any concurrency. As we said, actor cannot just freeze for a moment and do not anything and wait for something else. Actor should either operate, compute something, or be in idle. Messages are restricted to contain only information. We'll get back to that later. And last one, maybe not crucial for us as Android developers, is that order of messages is indeterministic. So at least in theory, if you are sending message A and B to some actor, you have no clue if that it's ordered to be processed. So it could be B and A. I know it was very abstract, difficult to follow the requirements, so let's try to analyze an existing system that can be modeled at correct actor model, and I selected for that traditional mailing system. Mailing system, we people are actors, and by messages, I will consider letter with plain text, traditional sheet of paper. So we all have unique addresses, my name, my street, and my city, so everybody from around the world can send me a letter. It lands in my mailbox. Of course, nobody knows which order will be in my mailbox and from which order I will start processing those, so reading those letters. However, I can assure you that usually we read letters one at a time. So I'm picking up first letter, processing it, and leave all the letters in the mailbox somewhere else. So now I'm reading the first letter. What can I do? The first thing that is allowed to react was to use my local memory, to use my knowledge that I know up to now. I can, of course, try to remember what's written there. This is my local decision. If I wanted to do something externally, I'm also limited by actors, model actor definition. I can either create new actor, and that would be like hiring a secretary to delegate work, or send messages. So I'm just replying to the guy that wrote me. I can as well send forward message to somebody else. Or I can also send a message to my secretary to say what to do. That's so far so good. We can now finish with that letter and take the next one. What happens if I suddenly die in such a system, on a heart attack, for instance? So the person that sent me a letter is still waiting for response, which will never arise. That's why you have to think up front how to deal with that problem and maybe involve some retransmissions, ping messages to overcome. One extra requirement for messages. Do you remember me that I said that messages are restricted to contain only information? So adding anything else to the letter, like money, it's prohibited. Why? Because post, during the delivery process, can take letter, put it into photocopier, and deliver only copy of it, and we should have no loss on any value. In case of putting their money, we will, of course, lose that. That's why it's prohibited. We cannot add any physical objects to our letters in order to use valid actor model. So what are benefits on some generic actors? First benefit is that we've got easy way to scale our system. We are just adding an extra items, extra actors to the pool of workers, like secretaries. Because none of our actors are actually waiting, we've got no logs, so the system works efficiently. Of course, if we are implementing it correctly. We've got well-modularized system by design because every single actor is self-contained element, so it's easy to maintain. And the last one, fault tolerance. We have to upfront during design process think about it because by design, by actors, you've got no support for that. That was an introduction about general actors. Now let's try to think how can be useful in mobile world. Because it involves a lot of distributed things in the example that I presented, but we are here with one single phone in my hand. Will we use it for everything? No. We will use, iOS and Android developers will use that only for problems that involve some concurrency, some asynchronous problems. Chris Lattner, creator of Swift, used a very beautiful metaphor that actors provide an island of serialization in the sea of concurrency. So we will try to reduce difficult problem that involve concurrency into a serialized string which is easier to model. But first, let's think, how do we traditionally would like to make our API thread safe? Assuming we've got some class with two functions, I suppose you already have an idea. We will just use GCD and serial queue for that. Looks fine. Now we are immune for multi-threading, but it gets more and more complicated if you are adding more extra features, extra functions, maybe some private helpers, and you may end up in the crash or deadlock if you forget it to implement correctly. There are at least two pitfalls. First one, manual handling. So as I said, you have to do it on your responsibility to manually enqueue everything on GCD serial queue. Second problem is that you've got no clue whether the third-party dependencies, so some object that you are relying on, are thread safe. So even if you implemented everything correctly from your point of view, it may still be not thread safe. Actors are going to address these problems. How? We will have an island of serialization. So within an actor, we assume there is no concurrency on the word, but of course we cannot say that it is invisible. We have to somehow overcome it, and we will introduce an extra layer that would wrap our actor that will enqueue all the messages coming to us. That was just introduction. Let's try to see in a visualized version. So assuming we've got two threads, A and B, that would like to send us a message. Some asynchronous or not at the same time, but we will have the wrapper that will not let two messages to come in, but only the one. And we, within an actor, are responsible to think, how should we behave? What should be the side effect of our message processing? We will create a different kind of messages to send somewhere else, depending in which state we are currently, and those messages will be delivered somewhere else. So as we had said in the traditional mailing system, as an actor, was able to only inform other parts of the system by sending letters. We'll use exactly the same here. So we will be passing messages. After we finish with delivering the first commands, the first side effects, only after that can come the second message to process. So within an actor, we are pretty sure we will be called only once at a time. Only one message will be inside our actor. And it will be done by external wrapper around it, so we will have manual queuing for free. I quite often refer to a term sending an action. What does it mean? You may think at the moment it's just like calling a function. Maybe syntax is different. So let me present you how can you represent your sending a message in actor word using a Swift example. I think it's self-explanatory. So rather than calling different functions with some arguments, like here we've got add and subtract with some arguments, we will just create a separate type that will have, most likely, it will be an enum with two cases here, add and subtract with associated values. And we are passing it to only one single public function to our actor. I call it send. If you remember, again, we are coming back to a problem that messages can deliver only information. What it means for Swift developers, it means that all the messages are restricted to contain full value semantics. What does it mean? It means that there is no shared state passed by the message, by the type. Maybe it's still not clear. So you may think of it like, is it possible to serialize that object into a string representation, then deserialize it back, and you've got exactly the same object as at the beginning. If you lost something, then it means it carries some additional shared state. That's why from time to time you may think, okay, maybe the messages requires to conform to codable protocol, and I would say technically it doesn't, but if you would like to, for some reason, do that, you should be able to write a lot of boilerplate, and you could just conform to that protocol. It's technically possible. So that's the requirement of messages type. It's technically possible to conform into codable. That will solve a problem about dependencies that are maybe not thread safe, because we can always use the serialized and deserialized version, which is definitely only our object, and nobody else uses that. Now let's go to the next part, Swift implementation. as I said, we will need some magical stuff, magical responsibility of an object, external object that will do this queuing for us. So we will not have to do for every single actor again and again. This slide is for convention of a naming. So I used naming that as an input. We will have messages coming into actor wrapped by a wrapper that I call the driver. The driver will enqueue everything on the serial dispatch queue, deliver to actor, and the actor will say us what kind of side effects he would like to make. Our actor is not responsible to actually doing those side effects. Somebody else is responsible for that. We'll get back to it in the real example, so I think it will be clear in a moment. So we have to implement once generic type that will make queuing. I think it's not important at the moment to read what's going on there. I would just like to inform you that there is only one publicly available function to send message to our actor, and that it takes strongly typed message. Why do we want a strongly typed message in our actor? Just because statically typed solutions are way better, and we can get rid of troubles of casting if we would have any type available as a message. That's why we have to somehow connect the input, actor, and output. So the messages, actor type, and commands. And for that, my implementation suggests to use 3 different protocols and to link with them with each other. And maybe you're now thinking, okay, cool, but you're going through troubles. There is a troublemaker, associated types. Maybe sooner or later you would need type erasure. And we know type erase is difficult. You almost need to be a rocket scientist to do that. And my answer for that would be, oh yeah, I agree. I may need to write type erasure. But the good part is that I can do it smart. Because what's the task for type erasure? For type erasure, we want to create any actor driver of specific message. And if you remember from type erasing how the process goes, that first in the initializer you're just keeping reference to all the functions of the original objects, and then in the any something you're using that when conforming to protocol. So if we have only one function, as I said, the driver has only one available publicly function, it means that we don't need to type erase anymore. Type erasure is actually one-liner, just a type alias. So it's only a function that takes message and returns nothing. If you remember from the very beginning, I said that actors are fire and forget. That's why we've got no return type of it. And putting everything together on a slide, we've got no more than 50 lines of code. So you don't need any library and dependency. You can just copy-paste your snippet and start working with actors. Obviously, you don't have to. If you'd like to do it manually for every single actor, it's fine. But if you've got a lot of actors, then definitely you should try with some better generic approach. I will go now into practical example of actor and real implementation. So I will give you a task, which happens very often as a task during interview. So please write me an application that presents to the user a set of elements on a table view, and of course the elements are coming from a backend server using HTTP request, and plus bonus points you will get if you do pull down to refresh. So that's the problem. First thing you have to consider is, does it involve concurrency? If not, then don't think about actors. And the answer is yes, it does, because most likely we will be doing the downloading from the internet. The elements will be done on a background thread. So maybe actor is good idea to shine on the interview. Okay, so how to implement that? That's a main slide to get all the implementation of our actor and our problem. I call this least screen actor that will be responsible for handling all the messages coming around the world. At the beginning, I will keep my messages and commands empty. We will fill them later. And I'd like, during the interview, to demonstrate my knowledge about Swift language. So I would say maybe being an enum type of an actor is a good solution. It's a very simple actor. That's why I think it's a correct way to implement that. This enum, least screen actor, will have only 3 different cases, 3 different possibilities to be. First one is initialized. So initial one, that it's blank screen starting of the application, then loading, and the third one will be presenting. I think that's self-explanatory. We are starting here with the initial state of our actor. We've got on the right the visualization of our current state. What happens first? User pulls down to refresh. So this is an action that we should handle. So this is a message that we expect to receive one time from our UI object. We don't care how is it implemented. It's not our business. It's not actor business because it doesn't involve concurrency. We just receive from somewhere a message. I call it reload intent. So let's add it to our message enum. We receive it, and it stops in front of our driver, in our gate, that ensures that no concurrency is within our actor. At the moment, the GCD queue is empty, so it will directly be passed to us, and we are coming into our function on the receive that we have to implement the body of it. It's a function. It's a mutating function because we may want to mutate our state. It takes one argument, message, and returns an array of comments. Again, array of comments are all the side effects that our actor would like to say to the external world. Because we've got such a structure that our least screen actor is an enum, so I suggest maybe we can use switch over a tuple of message that we are receiving and our current state. And using pattern matching, we will implement only code to handle messages we are expecting to receive. So those commands, those messages that we think are crucial and we should do something. So first one, we are in the initial state. We're now thinking what to do. Let's implement the first case. So we received the reload intent message and we are currently initialized. It's blank screen. What should we do? First, we should change ourselves into a loading state to inform ourselves that now we are not blank screen, we are not loading state. And then we are returning the set of commands, an array of commands. And at the moment, I would think that I should react by saying to my network layer to start the actual request. So I'm preparing this message to be sent, and then I'm returning an array of only one element. Let's add to the command potential case, and that's the end of our business. That's out of an actor. How is it implemented somewhere else? We don't care. Somebody else would need to do that. So in the actor model, you have to add some extra stuff to handle that. But I wanted to give you a broad overview what's actually happening out of our concern. So the message will be passed to some other actor. For instance, actor that will be responsible for networking. So it will pass over there, and the same as it is an actor, so there will be the same process, it will react somehow, and sooner or later, after a couple of seconds, it will produce some result. Let's assume that it succeeds all the time. No troubles with internet. And network actor would like to inform us that, hey, I've got response now. And as you remember, maybe, within the actor, between actors, communication happens always over the messages. So network actor has to send us a message. Cool. I call it results ready. We add it to our messages available, so messages that we are expecting within our list screen actor, and it will be delivered. Now it will be stopped on the GCD queue. And keep in mind, the response most likely will come from a background thread. And we were so unlucky that user was so impatient and also pulled down to refresh again. And we've got here a trouble because from two different threads, we've got the context of two different messages. We cannot let them inside. Only one of it should only enter our actor. And it's business of our driver, our dark blue wrapper to select which one. It's indeterministic. We don't care. I selected here, now we have to decide what to do. In order, we receive results ready message, and let's implement that. We are again on the receive function. We should somehow react on it. And here is the implementation. We are catching the tuple of results ready message, and at the moment we are in the loading. So we are looking, how should we behave in such case? In such case, we should say, okay, since now I'm not loading anymore, so I'm setting myself into a presenting state. And I'm saying to my UI layer, please present elements, and here there are elements for you to present. I don't care how do you do it. It's table view, I don't know. It's none of my business. So we will also add an extra case to our comment of potential side effect, and that message will be delivered to our UI. And only after we finish that, only after we set what our side effect is, the waiting message may arrive. And the process starts again. We will be entering the onReceive function, and we have to behave according to our business logic. To finish and make the entire task on the interview complete, I will add some different potential cases of our tuple, but I think you've got a point already. How can you implement that? Actors are great for modeling concurrency-related problems and eliminate bugs that you may come up, but also actors make unit testing easy. We all know that testing of an asynchronous code is difficult because you have to play with expectations, fulfill them, wait, etc., etc. And very often you lead into ugly code. But with actors, we will have a way better solution for that. If you remember, and I'm pretty sure you do, because we've seen several times this slide, from around the world, we are having a concurrency, but we will reduce it into our serialized island of serialization. So in our unit test, we will only observe what's on the output, what are the commands, if we are adding some message, if we are sending some messages to our actor. And we will always test it synchronously. Let's get into example. We've got here at the top the implementation that we already seen. And every single test starts with some initialization of an actor. Then we will send some messages and observe what are the commands, what are the side effects to perform. We are pretty sure that from within an actor, there is no extra global changes, like accessing the global variables. Because of that, we can definitely just observe the input and outputs. Very similar if you've got more complex scenarios, everything is synchronous. And here is even more complex scenario where that involves some reloading intent, so user is pulling down like a crazy and you receive some response from the server. So as you see, everything is line by line synchronous calls. You may think, yeah, actors are great. Yeah, this is a serial bullet, and unfortunately not. I think even the idea of queuing all the messages on serial queue is easy. You need a lot of experience to master it. So I would like to present you 3 different challenges that I faced in my problems and how did I solve them in production code. Problem number 1. At the beginning I thought, okay, so maybe I will send a message and together with some intent, for instance, please do for me a request to the given path address, and here is the completion handler that you will call after you will be ready. That's impossible. Yeah, that's breaking a law that messages contain only information. Or messages should contain only full value semantics, not a function, not blocks. How to overcome that? My solution is to use a unique address. Every time you start some request, every time you start something long-lasting asynchronous intention, you say, okay, here is the identification of that. If I ever want to cancel that, I will use that identifier. So for instance, you can generate UUID, which of course has a full value semantics, and every time you're passing a message saying what to do, you also include that identifier. That's solution for problem number 1. Second problem, timers. From within a timer, you may think, okay, I'd like to do some time hour exceeded after 60 seconds. Why don't I add it into my actor immediately? And that's prohibited. By the way, it doesn't compile, fortunately. But what's the problem? We are breaking the rule that from within an actor, there is nothing happening on magically. Everything happens over the messages. And the actor is able to react, to mutate its state only when it receives a message, then synchronous process it, and then return the commands. What's the solution for that? You have to create another object which is responsible to generate timer events. So you are extracting somewhere else, and then that other guy just informs you, okay, the timer elapsed, and so on. So we need to add an extra case to our message type, informing that given timer elapsed. Problem number 3, maybe that's not the problem, but I'd like to inform you, just to keep you aware, that we don't have throws and do catch support from a language because we are fully fire and forget mechanism. We are operating fire and forget. So the thrown error cannot be passed to a caller up. Solution, I didn't find any better just than doing it manually. So add an extra cases to the messages to inform that something happened. You have to do it manually. It's not difficult, but you have to, of course, create such extra messages and implement that. We are almost at the end of a presentation, so let's think about future of actors in Swift. And future is bright because Chris Lattner, father of Swift, it's a great fan of actor, and he wrote the document called Concurrency in Swift 1 Approach, which is not an evolution. It's just his personal opinion, how can be that solved, the concurrency problems. And he suggests that maybe one day Swift will support actors out of the box by a syntax. How? Chris suggests to add an extra keyword. That keyword will be the actor. An actor, it's a special class. You may think of it as a special class that seals all the properties, private properties of an actor class onto a serial dispatch queue. So you invisibly, the compiler invisibly will wrap your actor functions by async block, and only from that part you are able to access some variables available in the actor. If you wanted to access it from different functions, non-actor functions, so functions that do not contain this queue async, it will be compilation error. So you will have support from language for that. Second feature, I didn't assume what kind of threads we are working on, but Chris suggests that maybe one day we would need an actor that operates on UI thread, just to immediately access UIKit elements. And maybe it should be available out of the box by a language. He suggests maybe the main actor, maybe different name. It's still to decide. And the last thing, very interesting one, he proposed to introduce new protocol, value semantical. And as the name suggests, it will give you a full guarantee that given type has a full value semantic. And fortunately, that can be done by a compiler, so it will be auto-conformance protocol, just like equatable or codable. You will be not required to implement it on your own. It will be done for you in most cases automatically. Let's summarize actors. So we learned what actors, general actors are, what are the limitations, what are the benefits. We learned that for mobile development, we'll use actors only for troubles, only for problems that involve concurrency. Then we saw implementation in Swift language. You've seen my personal implementation for that. And at the end, I showed how Swift community is discussing about future Swift support for actors. Thank you very much. If you'd like to see how actors can be implemented in a bit bigger application, let me refer to my GitHub repository there, so you can take a look how actually it's working there with a lot of messages going around. Thank you very much. That's everything that I presented for you today. Regarding questions, organizers asking me to just go to corridor. So unfortunately, we don't have time for questions.